class. We'll do more of the applied problems today with the basic derivatives that we have. And then Friday, we'll learn the product and quotient rule. Is there any questions? Okay. We were on 27. So 27 is just another way of saying derivative. So I just wanted you to see that one. So you're just taking the derivative. The x to the 3/2 is in the denominator. We didn't learn a quotient rule yet. And the quotient rule has a lot more steps to it. So you'd probably want to rewrite this even after you learn the quotient rule. When there's only one term on top and bottom, bring it up. Remember, when you bring it up, it only changes the sign on the exponent, so it becomes x to the negative 3/2. Go ahead and take the derivative. Remember, multiply and then subtract 1. So when we multiply, you could write the decimal. 9 times a negative 1/2 is a negative 9/2, or 4.5 x. And then when we subtract 1 would be 2/2, so negative 3/2. Because they're both negative, you add them and keep the sign. And then negative times positive is a negative. 3/2 times 2, the 2's cancel and leave a 3. X subtracting 1, negative 5/2. So we multiplied and then subtracted 1. Any questions on it? Let's look at 28. I'm going to rewrite them first. So this first one, notice the 4 is on the radical. So that is x to the 1/4. This is the radical. This is the exponent on the original. And that would be x to the first. So it makes it 1/4. The second one on the x is a cube. That stays in the numerator. The radical, when there's a no value, the radical is a 2. So this becomes 3/2. Oops, I wrote that the wrong way, 2/3. No, I was right. The exponent's on the top. The radical's in the bottom. So the radical was the 2, the 3 was the exponent that was originally there. Any questions? Then just like the last one, we'd have to move it up first and then take the derivative. So go ahead and move them up. Remember, only change the sign on the exponent and then take the derivative. When you took the derivative, multiplied first and negative times positive was a negative. 1/4 times 8, you got 2x, subtracting 1, negative 5/4. Negative times negative, and the next one is a positive 9/2 x, subtracting 1, 3, 4, 5, negative 5/2. Any questions on that? My math lab should accept that. I definitely would accept it. If they want positive exponents, then you just bring the variable back, because only the variables to the exponent. So it'd be -2 over x to the 5/4 plus 9 over 2x to the positive 5/2. Any questions? Number 29. This little kind of like an apostrophe is, it means prime. This would be f prime of -2. F prime means to take the derivative and then plug in -2. So for 29, f of x equals x to the 4th over 6 minus 3x. So what you first want to do is find the derivative and then plug the -2 in. X to the 4th over 6, you could also write it as 1/6 x to the 4th if you wanted. My math lab will want everything reduced. For instance, this is the same as 4x cubed over 6, or 4/6, but 4/6 can be reduced. If you're plugging the equation in, my math lab's going to want it reduced. I'm not worried a lot about reducing. I want to know that you know how to take the derivative, especially when we get into the next section with the more complicated fractions and reducing. So leaving 4/6, I would not take off, but my math lab will. It will tell you to reduce. Minus 3x, this is a 1. 1 times -3 is -3. X to the 0 drops out because that's just 1 times 3 is 3. So that would be your derivative. And you could reduce this so your numbers are smaller. And then plug in -2. Now, also, sometimes they want the fraction, sometimes they will allow the decimal. If they're going to allow the decimal, they will say round however many places, round to the nearest tenth. Any questions on that one? Go ahead and try number 30. So for our derivative, 3/9, 1/3, so x squared over 3, if you reduce it, minus 14x to the first. And then plug in your 3. Everyone getting a negative 39? The next group is asking for find the slope of the tangent line to the graph of the given function at the given value. Then find the equation of the tangent line for number 31 and 32. I guess depending on what the answers are here, probably the fractions. I don't know. But 31 and 32, you need to find the equation. The slope of the tangent line is the derivative. So for 31, to find the slope, you take the derivative. So you write the equation first. So the slope of the tangent line is the derivative. And you should be able to take the derivative, especially right now, you've only learned the basic ones. So you need to be able to take the derivative quickly so that you can do the story problems. 4x cubed minus 15x squared. 2 is a constant. Remember, it goes to 0. So if you want to put the plus 0 till you get used to that, not a bad idea. Derivative of a constant is 0. And then we plug in our 2 to find the value for the slope. So on this line, every slope of the tangent line is this equation, and then at a certain point, you plug that x value in. In this case, we wanted it at 2. Getting a negative 28. 4 times 8 minus 15 times 4. Yep. Excuse me. So this is the slope. This is part of the point. To write an equation of the line, you need a point and the slope. Well, we have the x value. If we plug it into the original, we'll find the y value and then we'll have a point. So sometimes the point is given, sometimes you have to find part of it. We need to find y. We know that y equals, and we're plugging in the 2, so 2 to the 4th minus 5 times 2 cubed plus 2. Minus 5 times 8 plus 2. Now we have a point and a slope. Any questions on that? So this was the slope of our tangent line. To find the equation, we needed a point and a slope. And remember your formula, y equals, well, not mx plus b. We'll get it in that form, but we'll need the point slope. Y minus y1 equals m times x minus x1. Negative 22. Y minus a negative 22 equals our slope times the quantity x minus 2. And then solve for y. Most of them will want them solved for y. Negative and negative makes us a y plus 22. Distributing the negative 28. 56. Subtract the 22 to the other side. So this is the slope of the tangent line. This is the equation. Any questions? Let's try 32. Negative 3x to the 5th minus 8x cubed plus 4x squared. At x equals 1. Go ahead and find the slope of the tangent line. When you find it, type it in the chat so I know that you understand how to find it. So find the slope of the tangent line. Anyone find it yet? Yep, that's what I got, negative 31. When we take our derivative, negative 15x to the fourth minus 24x squared plus 8x. And we want it at x equals 1, so plug in your 1. Any questions? Okay, then we need to find our point. We have the x value, we weren't given the y, so we have to plug the point in to find the y value. Negative 3, negative 8. So I found the y value by plugging it into the original. Go ahead and find the equation of the line. So y minus y1, which is a negative 7, equals the slope, negative 31, times x minus x1. Distributing the 31, it's a negative 31. And negative makes this a positive 7, so I subtract it to the other side. Um, 24. Any questions? Okay. Find all the points on the graph where the slope of the tangent line is 0. Okay, so number 35. Find all the points on the graph where the slope of the tangent line is 0. Well, remember the slope of the tangent line is just taking the derivative. And if you want to know where it's 0, then you just set it equal to 0 and solve. So if we look at number 35, find all the points on the graph f of x equals 9x squared. What type of graph is this? 9x squared minus 8x plus 4. What
Quadratic.
type of? It's a quadratic, which means it's a parabola, and it's going up because this is positive. If we are looking for the slope of the tangent line when it's 0, that's at the highs and lows. Because this is a parabola, we should only have one. because there's only one value where there's a peak. It's a low peak, so this would be a min. To find it, take your derivative. 18x minus 8. Does everyone agree with 18x minus 8?
Yeah.
Because 2 times 9 is 18, subtracting 1, you get x to the first. This is a 1, negative 1 times that negative 8 is a negative 8, x to the 0 drops, and this is a constant, goes to 0. So if you want to see where the slope of your tangent line is 0, you take the derivative, because now this is the slope of the tangent line, and we want to know when it equals 0. And then just solve. Add the 8. Now this is x to the first, so we can just get x by itself. If it was squared, you'd need to factor or quadratic formula. Divide by the 18. Let's see, reduce by 2, 4/9. So this x value is where the minimum on the graph is. Any questions on that? Let's try 36. So this one wants to know where the slope of the tangent line equals -5. So first thing, find the equation for the slope by taking the derivative. Three x squared plus 18x plus 19. Any questions? We want to know when this equals -5. Now this one would be solved a little bit differently because we have a quadratic. So we want to bring the -5 over because it needs to be set equal to 0. So you can either use the quadratic formula, factor. So I'm going to add the 5 to the other side. Any questions so far? It might be factorable, but I do notice that 3 divides into each of them. So I could make my number smaller by dividing by the 3. Time you have something in front of your squared term, if you can get rid of it once you have your equation, it's a good idea. Even if you're going to use the quadratic formula, it makes the number smaller. Any questions? This one is factorable. There's 2 numbers. When we multiply, we get 8. Then when we add, we get a +6. Or you can use the quadratic formula. But the factor of 8 would be 2 times 4. When we multiply, we get 8. When we add, we get 6. So it will factor into x plus 2 and x plus 4. set both of them equal to 0. And get -2 and -4. So there are two x values where the slope of the tangent line is -5. Any questions on that? $37. For each function, find all the values of x where the tangent line is horizontal. Tangent line is horizontal when the slope is 0. So this means the same thing as this problem. If you want to find where the tangent line is horizontal, you take the derivative and set it equal to 0. So take your derivative, set it equal to 0, and solve. And taking your derivative, you should have gotten 6x squared plus 18x minus 60. Any questions on that part? Then we want to set it equal to 0 because that's where our line will be horizontal, or the tangent line will be. That is how you also find all of your max and mins. So relative highs and lows on your graph, you take the derivative, set equal to 0. Again, I can divide by the number in front to make my value smaller and see if I can factor. X squared plus 3x minus 10. Is it factorable? Anyone?
Yeah, with 5 and -2.
Yep, thank you. A -10 is 5 times -2, and when I add them, I get my 3. So it's x plus 5 and x minus 2. Now, if you can go right from this to -5 and a +2, that is fine. On a test, show as much work as you can so that if it is a careless mistake, you can still get credit. But the answer would be -5 and 2. So that's where there'd be a high and a low in the graph. This is a cubic graph, so it resembles a snake. It's increasing because the 2 is positive. So this is going like this. And there's 2 answers, which means there's a high and a low. The one is at -5. The other is when x is 2. And so you can find out where your highs and lows are by taking the derivative and set equal to 0. Any questions on that? That's where your tangent line is going to be horizontal. Try 39. So 39, the same thing. Find the X value where the tangent line is horizontal. So 3x squared minus 8x minus 7. Can't get rid of that 3 in the front. So you can either factor by trial and error or use the x that we've used to see if it's factorable. I'm going to use the quadratic formula. Quadratic formula always works, and so I just want to refresh with it. I think this is factorable. But some things are not, and quadratic always works. So if you want to factor it, you can, but I'm going to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And when you have a calculator, I mean, quadratic formula is not that bad, and you don't have to think about it. You just plug it in. A is with the squared term, so it's a positive 3. B is with the x term, so it's a negative 8. And C is the constant, a negative 7. Always take the sign with it. Negative B. Square root. Negative 8 squared minus 4 times A times C. All over 2 times A. I always do under the radical first. $61. B squared minus 4AC. Okay. So it's not factorable. 8 times 8. Plus 4 times 3 times 7. Getting 148 under the square root. Now, if you're going to enter it all at once, you have to put parentheses around the numerator. No, I just went 2 decimal places. On my math lab, they may want the exact value, which would be this. And usually they will make you write them separately, not put them plus and minus together. It'll say separate by commas. If it says you can round so many decimal places, then you can put this answer. If it doesn't tell you you can round, it wants these. Any questions on that? These are similar to what we did up here. They want the points. This one wanted the points. You need to plug back into the original to get the points. So we'll do one of these to make sure you know. We'll do 41. So at what points on the graph of f of x equals 6x squared plus 4x minus 9? Is the slope of the tangent line -2? Slope of the tangent line, take the derivative, set it equal to -2 and solve. (12x plus 4). We want to know when this is -2. This is x to the first, so it's linear. We can just subtract the 4. And divide by 12. If they just want the x value, then that would be your answer. If it says the point or points, then you plug it back into the original. If you turn it into the derivative, you're just going to get the -2. So if they want the point, you take that x and plug it into the original. And that will give you y. Any questions on that? That's 51. Is there any questions on those? Okay, 51. Assume that a demand equation is given by Q equals 5,000 minus 100P. Find the marginal revenue for the following production levels or values of Q. Okay, so first thing, remember revenue is price times Q. And so we need to solve this for the price because they want to give us values of Q to plug in. Assume that the demand is given by this. Find the marginal revenue. Yeah. So first we need to find the revenue function. That means this needs to be solved for P. Subtract the 5,000. And then divide by 100. And we'll get rid of the negative at the same time. So a negative 100. You can leave it as negative Q over 100, or you could, because remember when there's no number, it's a 1. 1 divided by 100. It makes the derivative a little easier, but that's up to you. So 1 divided by the negative 100 gives me this. And then 5,000 divided by 100 is 50. Negative and negative makes it a positive 50. Revenue is your price times your quantity. Negative 0.01 Q plus 50 times Q. Distribute your Q. So I told you that this revenue is price times quantity. It's going to be on every single exam. Just finding different ways of solving it. So that's our revenue equation. Any questions on that? Marginal revenue is the derivative. So we would take our derivative. 2 times the decimal is a negative 0.02 Q to the first. And then this is a 1. 1 times 50 is 50. Q to the 0 drops off. That's your marginal revenue function. And then you just plug in all the values. Double check that Q. Assume that a demand equation is given by, sorry, we're having tornado warnings practice today. Find the marginal revenue for the following productions. You just plug them each in, because if it said it was in thousands, then this would just be a 1, a 2.5. But it's not in thousands, so you plug in a whole 1,000. Sorry. But is there any questions on that? We'll do more tomorrow because I want to do 52. Any questions? Okay, I will see you tomorrow. Have a nice day. Where's my? Oh, it's over here.